In this example, I'd like to show you how you can interface your fingerprint scanner with a device like this, which is a 12-volt electric latch door lock. This is a fail-safe door lock. Fail-safe means that when there is no power in the device, like there is no 12-volt power here, then the lock is basically unlocked and people can open the door. This is just a safety precaution so that if there is, for example, no power in the building, power outage, people are not locked in the building, they can escape. If you've got a high security application, you probably want to have a non-fail safe lock so that if there is no power, then the doors will stay locked. In my case, I decided to go for the safe option. I still need to find a carpenter to come in and install this lock to the door of my lab, but I'll do that another time. All right, so I'll explain what's happening by having a look at the schematic. So the part that involves the Arduino and the finger sensor itself is identical from the previous two parts of this lecture. There's absolutely no change. What I've added is a tip 122 Darlington transistor so that I can use external 12-volt power to power the door lock, which is also 12 volts, plus an LED strip. So this thing here is part of an LED strip. I've put some tape around it just to dampen the brightness of the LEDs, but inside is just a normal LED strip like this, and the native power source for these is just 12 volts. So it matches the power requirements of the electrical door latch very nicely. So that's why I use the tip 122 here. The connections are pretty straightforward, and you've seen this kind of thing previously in the lecture on the tip 122 and the LED strip. So I've already gone ahead and done the connections here, and the next thing I'll do is to upload the sketch. So I've got the sketch here, I'll upload it, and then after I show you how it works, I'm going to walk you through it, at least its most important functions. So let's go ahead and upload it. All right, done. So what I'll do next is I will remove the USB cable and just power it with my external 12-volt power source. Okay, and now apply the power on the power supply and turn it on. All right, so what's happening now is that I've got 12 volts applied to the door lock by default, and you can see that the latch is closed. When I have a successful fingerprint match, then power is discontinued from the door lock so that the latch moves and the person can get out of the room. Then 10 seconds later, power goes back on and the door is locked. And that's indicated also by the LED strip. So if I try again with my thumb, power to the door lock is cut off, person can get out, 10 seconds later power is applied and the door is locked. So it gives people 10 seconds to get out of the room. So it's a pretty simple setup that I've got here. Having a look at the sketch, this is where I define the object for my fingerprint sensor. I set up a few variables that I use to count the time. Sorry, it's 5 seconds and not 10 seconds, so 5,000 milliseconds is the interval that I've set, and the lock pin is 9. So digital pin number 9 will pass a signal to the transistor to disrupt the power, or to stop the power, or to allow power to flow through to the door lock. In the loop, In the loop down here, you can see that every 50 milliseconds I'm calling this function called get fingerprint ID EZ. And if you have a look at that function down here, you can see that three things are happening. First, the sensor will get an image of the thumb that is on the sensor, and then it's going to convert that image into a template. So it says image to T, image to template, and then it will try and match that new image that was just captured against templates that are stored in the internal database. And if it finds something, then it will say so, and it will display that in the serial terminal if that's connected. In my case, I disconnected the USB just to approximate how it would be used in real life at a door instead of connected and tethered to a computer. If there is a confident match, so if the confidence is over 50, you can see finger.confidence. We get that as a result of doing the fast search. If it's over 50, then we'll go ahead and turn the lock off so that the door can open. And that's about it, pretty much. So this is the function that you need to insert to your own sketch if you want to apply the fingerprint sensor to another security application for your projects. It's fairly simple, I think. Okay, I'll turn the power supply off just to reduce the noise level here. So that's about it with the demonstration of the fingerprint sensor. It's a very nice, reliable device. I'll have some additional documentation in the lecture description and notes for you to look at. I hope you find something interesting to do with it. And of course, if you have any questions or comments to make about this lecture, please feel free to use the forum.